Hello everybody, this is Dr. Maria Weber, and I wanted to walk you through how to do the online circuits lab that we're having you do this week using a kind of online lab simulator called PhET. Here for the lab for this week, it's called Series and Parallel Circuits. You are going to use an online lab simulator in order to do pretty much the same lab that we would have done together in class. Okay. So here's an example of 3 different types of circuits that we would have done together in class. This is what they look like in real life, and you are going to work through and build your own circuits exactly like this and take your own measurements and walk through these problems that I have laid out here in your quiz instructions. So you're just going to follow along with these instructions here, and I will show a few examples of what we're doing here. Okay, so here you have the link to click on for these interactive simulations. Here is where that link will take you. If you click there, it'll take you to a page that looks like this. Now we're going to build our own circuit. You see that we have circuit components on this side right here. The first activity asks us to build a circuit that has 3 resistors in series. So here's what we're aiming for. We have our battery here. We've got 3 resistors. The first one has a resistance of 30 ohms, the second a resistance of 50, the third a resistance of 100 ohms. And then it's going to ask you to do a few different things with it, and it's going to ask you to eventually make measurements of the current and voltage across and through each of these resistors. So let me show you how to do that. You can follow along with these instructions here. I'm also just going to do it right here so you know what we're doing. So we have to have a battery for a power source. I'm going to drag it in right here. And if I click on the battery, I can change the voltage of the battery. I'm asking for 10 volts here. So there we go, done. And now I need to add some wires. I'm going to add some wires in here like this. And I want 3 resistors in series. And what I do is I'll grab a resistor, place it in here, okay? And then I'm going to put another wire, place my second resistor, okay? Grab a third wire, place my third resistor. Here we go. Okay, I'm trying to make them kind of straight for you here. Sometimes you have to play around a little bit with them. And then I need to take this wire, attach it here, and then I need another wire that goes straight up. Okay. There we go. So this looks pretty similar to this figure right here. Oh, and now I need to click on each of my resistors and give them the appropriate resistance. So click here. The first one needs a resistance of 30 ohms. Second one needs a resistance of 50 ohms. Okay, oh, almost there. And the third one needs a resistance of 100 ohms. It's almost at the upper end of what we can do here. Okay, and you can see that the color bands changed on the resistors just like they would if we were using different resistors in lab. We talked a little bit about this, how resistors have different bands on them that tell us the resistance of each of those resistors, and there's a particular code that goes along with them. Now, you see here I have clicked up here in the corner where it says show current. I've clicked on the electrons. So you see the direction in which the electrons are moving in the circuit. If I click the other one, I see the direction of the conventional current, which is the direction that we're going to draw current in our class. And you can see how that current direction is related to our battery here. This would be the positive terminal of our battery. This is the negative terminal of our battery. Now we need to take measurements. And the easiest measurement that we can take is the voltage drop across our resistors. And to do that, I'm going to grab my voltmeter. And I'm going to take the black probe and put it on this end of my resistor. The red probe, put it on this end. And look, it tells me the voltage drop across this resistor. Now that's resistor 2. To get it across resistor 1, I'm going to put it right here. To do it across resistor 3, I'm going to place it right here. And if I ask you to find the voltage drop across all of the resistors together, then I'm going to place the black probe down here and the red one up here. So the voltage drop across my whole collection of resistors in series is 10 volts. That's the same as the voltage that I placed on my battery. Okay, so now I'm going to remove my voltmeter and bring over something called an ammeter. These are a little bit more tricky to deal with. Now, the voltmeter we put here in parallel with all of our resistors. The ammeter has to be in series. And so I asked you to find the current through each one of these resistors. Now to do that, what I have to do is I have to put the ammeter in series, and I'm going to put it right after each one of the resistors that I'm trying to measure. So what I have to do is, if I want to measure the current through resistor 1, I have to remove this wire right here. I'm going to delete it and place this inside here. I have to move things around a little bit. Okay, so now the ammeter is reading the current that is moving or flowing through my first resistor. It's saying that it is 0.06 amperes. Now to get rid of it, I just click on it and trash can. Now I'm going to bring my wire back so I get current flowing through again. And then if I want to measure the current through my second resistor, I'm going to trash can the wire and then place my ammeter in there. I'm going to orient it this way so that it just slides right in there. Okay, now it's measuring the current, same current. And then I'm going to connect my wires back up again. Let's tidy everybody up and remove that there. Place my ammeter right here. Okay, also 0.6 amperes. So because these resistors are in series with each other, the current running through all of them is the same, which is the same as the total current in our circuit. Okay, so now I'm going to remove that and bring back my wire here, and now we're back with a current flowing through our circuit. Okay, so that's the first circuit we want to build. The second circuit I'm asking you to build, an activity 2, here is those same resistors, but all of them in parallel. So I have to rebuild my circuit. I'm going to delete all of these wires that I don't need right now. Okay, and then I'm going to place all of my resistors in parallel with each other. So I'm just orienting them like this, and then I'm going to bring my wire through, and then I'm going to connect them all in parallel. And so you can just try to match up those figures that I have for you in the instructions, so that you're sure that you're doing everything correctly. And you know that you've got everything connected up if you see the little arrows showing you that current is indeed flowing through your circuit. Okay, and there we go. Now I just need to connect the third one in here. Almost there. And this wire here. And that one there. Okay, cool. Now, I also need to measure the voltage drop across each one of these individually and the current flowing through. So a similar thing, same thing with our voltmeter. Place the voltmeter across the each one of the resistors like so. Oh, let's just check that I placed the resistors in the right place. 30, 50, 100 ohms. Cool. And just do that across all these. To get the total voltage drop across, I'm going to connect here and here. So total voltage drop across all of them should be 10 volts there. And you'll discover what it should be across each of the individual resistors. But you should remember that if you remember our rules for resistors in parallel and what the voltage drop across them should be. Okay, now for the ammeter, similar thing. I'm going to delete that wire there, place the ammeter right in through here. There we go. Now I'm measuring the current moving through this one here. Okay, so I'm going to delete that, and then you do the same thing for each of them. And then to find the current across your entire circuit, maybe I could, because here you see that the current is splitting off into different directions, different directions, different directions. But right here, the current hasn't split off yet. So I could remove that wire and place my ammeter right in here in order to measure the total current running through my circuit. Okay. Now trash can that one, and we need to do our final circuit. The final circuit looks like this. Is a combination of one of those resistors in series with two of these resistors in parallel. Okay, so to get that one, let's see, we'll just start deleting some of these wires here. I want my 30 ohm resistor to be in series first. So let's place it here. Okay. And then, yeah, that's the 30 ohm one. And then we want to connect these two in parallel. I can get rid of one of those, connect that there. So you can just sort of play around with tidying all of these up here. It looks like I forgot to add a, so we can cut it apart like that. If you forgot to add a particular wire, I'm gonna stick it in here. There we go. So now I've got that circuit that I was aiming for. I've got my 30 ohm resistor here in series, which is then in parallel with my 50 and 100 ohm resistor. Okay, and then same thing, take my voltmeter, measure across the resistors to get the voltage drop across them, and take my ammeter here, and I can chop off part of it and connect. This is the total current running through my circuit then. Wire back if I want to find the current, let's say, moving through this particular circuit or this particular resistor here. I'm going to chop that off there. I can place my ammeter right in here. There, and it's a little wonky. There we go. And this one's measuring the current that's running through this first resistor. You can test yourself, but you will get the same answer if you took this measurement on the other side of this resistor as well. Okay, so there we go. That's how we're going to set up these three different experiments, just like how we would set them up together in lab. Okay, so I hope you have fun with this. It's kind of fun. Maybe play around, see what happens whenever you change the resistance of your resistors. Maybe you want to create a really fancy circuit that's way fancier than this one. Here, there's also switches, which I haven't used, but you could place a switch here in your circuit. Let's say we wanted to put a switch right here. Okay. So then there's no current flowing through my circuit, but if I connect my switch, click the switch to connect it, close the switch, then we get a current running through the circuit. You can also do other interesting things. Let's see, you could add a light bulb and see what happens. We placed a light bulb here and here. You see that it lights up. Let's remove. Yeah, let's remove that, trash it, and try something else. What happens with the paper clip? You can make a circuit with a paper clip too. Paper clips are made of metal, they're resistors. Let's see what happens if we replace it with an eraser. Well, nothing, because an eraser is essentially an insulator, and so there's not going to be any current that will flow through if we place it in there. What happens if we place a dog in our circuit? Oh, apparently nothing. Okay, what if we place a pencil? Oh, that we can get current flowing through with the pencil. Well, the pencil inside has graphite, which must be a little bit of a conductor as well. So again, just play around with it and see what you can construct. But the first few things I went through is what we need to do in order to complete this lab. But you can also play with the resistivity of the wires if you wanted to, and the resistance of the batteries. If I click this button here, everything will be in schematic form, like the drawings that I've been doing in the videos. Okay, so if you have any questions, let me know. But these little PhET lab simulations are pretty cool, and they're going to enable us to continue on with the rest of the semester doing our labs remotely.